So once again, with fault finding, we get test results. Now, when we've done test results before in inspection and testing, we get a test result and we get those figures and we need to write those figures down. Sometimes with test results, we just want a yes and no answer. So we're just going to have a look at the test results. So interpreting the results and information. It is at this stage you apply logic and reason to your observations to determine the problem area of the malfunctioning equipment. Often when equipment malfunctions, certain parts of the equipment will work properly while others will not. The key is to use your observations and data to rule out parts of the equipment or circuitry that are operating properly and not contributing to the cause of the malfunction. You should continue to do this until you're left with only the parts that, if faulty, could cause the symptom that the equipment is experiencing. For example, it is found that a large electrical circuit has an installation resistance fault between line and neutral. To narrow down the location of the fault, use the half and half method. Go to the middle of the circuit and split it. Test in either direction to identify which half of the circuit has the fault. Then split the fault in half, in two, and repeat until the specific location of the fault is determined. To help you define the problem area, you should have a schematic diagram of the circuit in addition to your observation notes. Electrical faults fall into a number of categories as follows, and we've looked at this in a previous. We have high resistance, we have transient voltages, insulation failure, excess current, short circuit, open circuit, and earth fault. The following are some rules of thumb where prioritizing problems caused. Although it could be possible for two components to fail at the same time, it's not very likely. Start by looking for one faulty component as the culprit. The following list shows the order in which you should check components based on the probability of them being defective. Look for components which burn out or have a tendency to wear out, i.e. mechanical switches, fuses, relay contacts, or light bulbs or lamps. Remember that in the case of fuses, they burn out for a reason, and you should find out why before replacing them. The next most likely cause of failure are coils, motors, transformers, or other devices with windings. These generally heat and with time can malfunction. Connections should be your third choice, especially screw types or bolted types. Over time they can loosen and cause a high resistance. In some cases, this resistance will cause overheating and eventually will burn open. Connections on equipment that is subject to vibration are also likely, especially prone to come loose. Finally, you should look for defective wiring. Pay particular attention to areas where wiring installation could be damaged, causing short circuits. Do not rule out incorrect wiring, especially on a new piece of equipment.